Hello, welcome to data handling with Python. I'll start by sharing the original web page for those who have just joined us today. This is the web page very quickly for lesson 4. So we are formally in lesson 4, but for those who have joined us, it's the first lesson. We are in data handling. So if you look at the Moodle of this course, at the top, there are different tabs, and we are in the data handling part. Top is Dataframes 1, and that's what we are going to do today. So there are some instructions there. I leave it for you to download the notebooks and the data and PDFs if you like. Also, some video recordings are there. And when we have finished this webinar, then I will be putting up the recording of this webinar as well. So I'll just go into the middle of things. We want to have now access to functionality within Python of a library which is called Pandas, just illustrated by this logo behind me. And we're going to use Pandas to import data, get an overview of the data, and find some basic visualization techniques that will be very useful and extensively used in the machine learning part. I will also introduce how we go from a Pandas data frame to the NumPy arrays that we are actually working on when we do the machine learning. And here we want to now have a look at how to get the right functionality and how to use it. So that package, Pandas library, that's already installed when you have used the Anaconda distribution of Python. So from Pandas, it's the name here, from Pandas we have to import, and because we have only a limited number of functions that we are going to deal with, we can have a look at them individually. We don't need to import the whole library. So read CSV would be the import functionality to actually read from a Python kernel a file that is stored physically on our computer. Right, so having imported that, we can use it, and read CSV is the name, which will be auto-completed, and it takes as an input argument, unsurprisingly, the name of the file that you want to read. So the name goes in quotes. I use single quotes, sort of read as a string, and you can specify the path to that file within the quotes here. So I put D, and what I have to do first is to find the folder where my data are. So I recommend on the web page, and also if you read the materials, to store your data files in a separate folder called data, so that they are sort of put away from the actual code, and it's a file called data. So the first thing is I access that folder, right? So you can see also the folder goes into the name, and then the data file starts with E, it's Everly subdata, so it auto-completes once I put the E there. So read CSV and specify path plus the actual file name is sufficient. When I execute the code, it imports it and displays whatever the function returns, in this case, the content of that file in a specific format. Now that is of course not enough. We need to handle that. So we need to put that into a variable, and the variable often we use just df, especially for demo purposes. Also many tutorials will use df, that's for data frame. So if you have learned to deal with our data frames, this is very similar here. And then we can have it, if we just specify the names, JupyterLab will give us the content displayed below the cell in a similar way as we saw before. So we have read the file, we have there now the numbers and indices and the labels, and we'll have a look at this one by one now. So if we scroll down, you can see that this goes to index 17, which in Python notation means, or Python indexing means it's 18 rows. And of course, in your data file, that might be 10,000 rows. So to get an overview, it's the first function that we apply to the data frame. We apply it in the dot notation, object-oriented notation. So df, data frame dot, and then the function that you want to use. In this case, head, function with round parentheses. If we leave it empty, we just take default settings, and it shows you the first 5 lines of the data frames. If there were 20 columns, it would show you all the columns, only the first rows. So it's easy to get an overview and not to see the whole thing, but just a little bit of the beginning. And the main argument that it takes, you can see 5 lines display here. If you put df head and in parentheses number 10, integer 10, then it will display 10 lines as the number of lines as the first argument. And if you specify 1, it will only show 1 line. So you can sort of manage whatever you want to see. Okay, the same information about the information about how many rows are there. So if you want to have that number, you get it with something that I think everybody who uses Python knows, and that's the len function. So if we apply len and input that data frame as an argument to length, it looks for the length of that data frame, and length meaning number of rows of it. And it tells you there are 18 rows. Next thing, just one by one, call columns. So there's now an interesting thing called dot columns without round parentheses. And this tells you there's like here given like as if in a list with square parentheses, calcium and sodium. So it tells you the columns that are there by the names that are given in that title line. And of course, if you have those columns, you can then count how many are there, and the list that contains all the titles will then tell you the number of columns that are there. So length of df.columns gives you the number of columns. So we have now both the length, the number of rows, and the number of columns. If you want to have both, you can use shape. Shape tells you 18 rows, 2 columns in the notation first, in the convention, first rows, then columns. Right, so that's good. So we have 36 values here arranged in 18 rows, 2 columns. And if you see that in the future, maybe you remember anything that is followed with the round parentheses are functions that typically expect input arguments. And if you put the empty round parentheses, it means you're using default settings, but there are input arguments to be provided. And if you have something that doesn't take it, like columns or shape, these are properties. You can find that out by getting the online help for it. So going on that property name or whatever name that is here, and having, shift tab, it shows you that this is not a function, this is a property, and that doesn't need round parentheses. And it returns you these 2 numbers, which you can store in a variable and then access as 0, index 1, if you need them, if you need to know them. So dataframe.shape is the way to get both numbers in a very convenient way. Now we need, of course, access to each of the items in that data frame. So that lets us think of indexing, like we have started by indexing lines and lists and tuples and string and so on. And now we want to see how we can index the data frame. Actually, there are many ways to index a data frame, and I want to show you one and also encourage you to practice the one where we index the data frame in a way that is very consistent with what we are later going to do with NumPy arrays when we do the machine learning. So this is the way that you should get used to. The other ways with double square brackets and so on is also nice, and you will occasionally be able to use it, but the one that we really recommend practicing if you're not already used to it is iLoc. So index locator, in the indexing goes very similar to what we have started to learn with Lisp, but in a nice way that is also done in other programming languages in the convention rows, comma, columns. So if we use the colon, which means all, comma, colon, colon, comma, colon means rows, comma, columns, all of each, all of both, and then we will just see what we have in that data frame, everything, all 18 rows. And of course, now you can see by this column notation, all the slicing rule, all the indexing ways in Python apply here. So if we want to just see the first row, then we type 0, all, we see all columns, we see the calcium value and the sodium value, those two. If we want to see everything up to row number 10, then it will go up to index 10, excluding index 10. So this is the first 10 rows from 0 to 9 in index. And of course, you can also specify that you only want to see the sodium values, and then you say 1, and these are just the selected values from the sodium column. And yeah, that is something that I suggest. Try it with this example data set, any of the other data sets that are provided for download, and make sure you are very comfortable with it before we go to the next round. And what we will do, I have mentioned this already, we will actually not handle data frames in machine learning, but NumPy arrays. So the best is to immediately know how do we get from one to the other. How do we get the NumPy array once we have the data in a data frame? So we have read our file. Can we get it into a data frame? Can we get it into NumPy arrays? It's very easy. df dot, like for anything. So make it a little bit bigger so you can read it better. Thank you. And df dot access the data frame, and now to sub NumPy. So the function is to sub NumPy, convert to NumPy array, and you can see the output is immediately the data in a new format, array indicating NumPy array, and we have double square brackets, which reminds us of a nested list, probably, if you have done the previous lesson. And this is the way we will handle data in the machine learning environment. And it's not just us, this, almost everybody in the world uses this. So if we wanted to have that, we can say our data are then obtained from the data frame, just get it as a NumPy array. And then, of course, if you want to see something of this, the same that we did before, 1 to 10, 0. If you want to see the numbers and you want to access the numbers, take fewer, take just the first 6, so they not even first 5, so they fit in a line. Up from 1 to 5, so that's starting from 1 up to index 4, this 4 numbers, and they are 3.6 and so on of column 0. And if we wanted the sodium values, they would be column 1. So this is then very the same as we did with iLoc on the data frame. So if you get to know these two versions, it's nothing new to be learned. This is consistent for the rest of the course. Okay, coming back to our data frame. So today's lesson is data frames. So data frames have another way of accessing the elements of it. And This is one thing that we can use the name, especially. Let me first bring that back. The data frame looks like this, right? So it has a title above each column. One is calcium, one is sodium, lowercase letters. So we can use that title to access the values in that column. So let's do that. We do that in square brackets, and we just give the name of that column. So if we specify calcium, and it's a string because it's a name given to that column, then we will only get the calcium values, and equally, of course, if we specify sodium, we will see the sodium values displayed. So it's another way of accessing it. And if you have done dictionaries in Python, it might remind you of calling the values in a dictionary by referring to their corresponding key. So this is actually what's going on in the background. And so here it works to access individual numbers from a data frame. Right, so there's also then a way of indexing this further, which I don't go into, which is described in the materials. But now that we can sort of see how that works, let's do a thing that we did like 4 weeks ago, which was iteration. So remember, we learned how to iterate through a list, through a tuple, through a dictionary. And we can do the same thing with a data frame. And say for column in DF, so we can iterate through the columns in a data frame. So let's have a look at this by first, of course, usually you remember the way we learn how to see what's going on in a for loop is to just print whatever is there. So we have called the individual items column. So let's just run this for loop and say print the column, namely which columns do I get? And of course, iterating through the whole data frame will give me all the column names. It doesn't give you the values, it gives you the names of the columns. In this case, it's 2, but if there were 20, then it would show you all 20. So let's now modify the code and get access to the values. So I just copy and paste it here. How would we do that? Well, do you know how to get the values of a dictionary? You refer to the key, right? So what is the dictionary? What is the data frame here? It's called DF. And then in square brackets, what I just showed you, you can put the name of the column in square brackets to access what is in there. So let's just do that because the columns are now called column, each of them called column. So let's print now the DF at the column with the name column. And that shows you numbers. And if you scroll down, first one was the calcium column, followed by, if you scroll all the way down, the sodium column. So that displayed you now all the values of all the columns that were in that data frame. And if you think it's a little bit too long, if you say now from that column, let me see just the first 3 lines, also using a second pair of square brackets, you can specify what part of the values you want to see. So if I just say up to 3, then it will show you the first 3 values in each of the columns. Simple, right? So this is the double square brackets notation here. If you have all data in that column, then you can slice through them, putting second pair of brackets. And then we can see this, and of course, all the other slicing rules apply similarly. Okay, so you get a feel, hopefully you get a feel for how this all looks. Import the data, get an overview with head, for example, anything that you like. And then you can access those data and have a couple of things specified, number of columns, number of rows, names of columns, all those things that you can see here, and many more, of course. Right. Okay, now it's 2:30 already because of that delayed start. maybe we'll just have a shortcut here a little bit. I don't want to go very much into doing statistics here. And another function that you can use to get an overview, or one of the functions to get an overview of basic statistics of your data frame, is to use describe. So just spelled as the English word, describe, and that's a function, so with round parentheses. If you don't add, just use it by default, then this is what you get. That's all. So we can see the whole output of df describe, and of course you can put that into a variable. This, I think it was called description in the material. Description. And the description, if you store that variable, then you want to see what's in it. Description. And now we have our description seen here below. And what it gives you is a basic statistics overview for each of the columns, right? 2 columns, now 2 columns of output from the description. And you can see here, the columns have the same names as before. So it took the names from that data frame and displays it here now. And on the left-hand side, instead of the indices, you can see count, mean, STD, standard deviation, min, 25, and so on, down to maximal value. Which is quite suggestive because count means how many are there, 18 values. Not sure why it gives that in decimal notation by default, but there you go. And then gives you the mean value, the mean of the calcium column, that is, it's 3.17. Mean of the sodium column is much bigger, it's 115. That's of course due to the different average concentrations of, in this case, extracellular blood plasma, calcium and sodium concentrations. Standard deviations for each of the columns, the minimal value, the maximal value at the bottom, and in between the percentiles covering a range of those 18 values that we have, where 50% then happens to be the median. So that value that cuts the data set into 2 halves. So I don't want to go further into this, but now you have it in description, and you can access each of the values in description and work with them, especially if you have, for example, the mean for each column. And now we're thinking, of course, of bigger data sets. You have like 100 columns. You can get the means for all of the columns. Then you can, of course, do look at all of the means that you have in that whole data frame. And for example, looking at the distribution of the means of all columns. So you can work with the distribution of means or the mean of means or whatever you like. And finally, description. If you know, one thing that we always need to check in Python if we are not quite sure is the type. What type is it? So description is a variable that we have produced by using the function describe on our data frame, right? So what did it give us as an output? Oh, another data frame. So the result here now has produced a new data frame, which is the summary statistics of that original data frame that was called df. Okay, first part finished. Hopefully it works for you. Let's now go and do the exciting thing, that is, how do we do visualization in Python? For those who have been waiting for it, sorry you had to wait so long, but let's do a few basic steps into visualization, because of course there's no such thing as data science or machine learning without displaying the results as graphs. So I've started a new kernel. So let me, for reading, you know this already, read CSV. I'll import my data frame as before, and it was data frame equal read CSV And my data set was the Everlease data, those two concentration columns. And here they are. If you don't want to see the whole thing, just show me dot head. Just show me the head, and there it is. There are the first 12 lines. Of course, it's the same thing as before. So it's in a variable called df. And for the plotting, if you read the materials, there are some convenient ways of plotting the data or analytics of the data realized in Pandas. So similar to R, there are some nice functions where you quickly get a nice graph from within Pandas. You can look at it and you all do it like the way we did it before. df.hist will give you a histogram of the data frame. df.bar will give you a bar chart of the histogram. df.plot will just plot you things. But we do it a little bit differently, because what happens when you call one of the functions in Pandas, so one of them related to done to operate on data frames, is that in the background it accesses a library called matplotlib. And because that's sort of the real thing in the background, we want to go and learn to handle visualizations using matplotlib directly. So what we do, we import functionality from there, and matplotlib, just get used to it. This is something that you will use a lot. And we use the plotting library, which is called pyplot, and we import, and I think we're fine importing only one thing today. Only one function is enough, so I import that function directly. It's called subplots with an S at the end. There's also a subplot without the plural S at the end, but what we need is subplots. So that function, like the Retsius, we just import it at the top of your script, and then it's there, and then you have it and can use it. Now, I'll show you how that works. So subplots is a function to generate a figure environment and to put a coordinate system into that figure environment. Right, so we give it two names. So we unpack those two things. We get two things out of the function call. First is fig, that's the figure environment that sort of opens the environment where the figure is placed. And then we have a coordinate system, which you can call CO or axis or whatever you want to do it. Names are arbitrary. And that's how you do the function call. And we first start by using just defaults. So fig, ax, figure and axis from that function call, and you can see it gives you some default coordinate system. And this is where our plot will go. And you can guess from the name subplots that this is flexible enough to handle any number of graphs that you would like to do, so including any subplots or subpanels up to publication quality figures. Okay, so let's do one. Let's get with this command, figure x equals subplots. Then how do we do it? Now we need to actually plot something. So axis is AX is the abbreviation, or is a variable that calls the axis, the coordinate systems where things go. So axis dot, then whatever follows, whatever functionalities there, will put something onto the axis that we have just defined when we called subplots. So a simple thing that you can do is box plot. So let's do that. Let's have a look at the box plot. And we can do it on the data frame and specifically on a given column. So we have learned how to do that. The first column will be called calcium in single quotes. So we can get a box plot of the first column called calcium in a variable called df, which is the data frame containing, if we scroll up, two columns, one called calcium, one called sodium. So if we now execute that code, first thing is what we will see is a lot of things that are of no interest for us in this moment. Maybe later, but I can show you if you're not so much interested in seeing all those extensive comments here, the way to suppress it, to put a semicolon at the end of that last call that we did, the last call, and then we can see the box plot just in splendid isolation. Right, and that's what we get. We get a single box plot, depending on whether you're familiar with it or no. It just shows you basically the output of what we first created when we used describe. Like the description, the output of describe, the basic stats is summarized here in the box plot with median, which is here in orange, and then the box covering the 25 to 75 percentile, and then the whisker specifying how many more values to get to 75% total, and then the outliers with little small circles also according to some internal convention by how to make those whiskers here. And okay, we don't go into discussing the box plot, but if you replace calcium with sodium, you get the same for the sodium column. And you can see the values are now much higher because these individual values were higher. Right, so you can have a look at this and try to interpret it. Let me just show you one first argument of the subplots call. So one that you probably will use a lot once you get to doing proper figures that you might save and put in a document. So subplot takes in many keyword arguments. So let's learn one, and that is the fig size. So if you thought that fig size is too big or too small or whatever, you can specify the figure size by specifying the fig size keyword argument. And what you do is you say fig size equal, and then in round parentheses, which denote a tuple of two numbers, you specify the width and the height. So if we do 6 by 6, I don't know how that turns out. That turns out now fairly big. Let's make it small because my screen is showing fairly large. Still too high. Let's make it 4 by 2, and then we can see it on our expanded screen. Right, so the fig size gives you access to controlling the width and the height in that order of that figure. And so that helps you, if you need it very wide, you can also stretch it out over the whole line and so on. So whatever you prefer, keyword arguments in the subplots call to arrange the figure to fit nicely on your screen. Okay, if I just use that very same code, copy and paste it, we can have a look at a different type of plot. So now we see the box plot, and you can get the overview, plot the two next to each other, see how calcium compares to sodium and so on. Let's have a different plot. The only thing that we need to do is we substitute box plot with something else. So you can try bar for bar chart. That will ask more arguments, and plot for plot. And we can also do, if we already look about, not HIST, short for histogram. So HIST is the histogram, see if it works. And there we have our histogram. Just by default, just calling the column that you're interested in, you get the histogram that you want, in this case of the sodium values. And it's taken in all 18 values, and you can see around the 100, you can see 3 values recorded, and around 110, there's only 1 value. 130, a little bit above, is 2 more values, and so on. So these are the ways to specify, and there's of course an interesting keyword argument in every histogram. Histogram involves binning. That means putting numbers into containers and counting how many there are per container. So of course you want to control the width of the container. And that keyword argument is bins. And I forgot, was it 10 by default? I think it's 10 by default. That's what we have here. And you can specify less to get wider bins. So if I say 5 bins over the range of values encountered, so you can see that eternally checks min and max values, which we got from description before. So describe gave us the min and max value, and that's how it sort of puts the bins automatically. Or if you want to have more bins like 15, then the bins will be narrower and you have less counts per bin in general. Right. So this is setting up a plot in Matplotlib, and that works with data frames. It works with NumPy arrays. It also works with lists. But that's why it's very flexible, and we can use it. And let's do one before we end, and that is to use the actually subplots to make more than one panel. This is often very nice to have two things next to each other. So let's just start doing this again. And fig X now to create, every cell needs to create its own figure environment if you want to plot a new figure. So that was subplots. And we have now maybe fig size. If we use that from before equal, what was it, 4.4,2. And then we can specify how many panels do you want. That keyword argument, of if we use it as a keyword argument, is called encalls number of columns. Okay, let's say 2, keep things simple for the moment, and then try to make a plot where we want to have two things plotted like the histograms of calcium and of sodium next to each other. Just some primitive examples. So now we have two columns specified, right? So we have created axes with the specification that it should be two columns. So we need to access each of the columns separately. And this is easy if you know indexing, because the first column is 0, index 0. And so if you want something plotted there, you make your, say, box plot there, or say histogram. Let's do the histogram. So do the histogram. Open close brackets, and then define data frame, and in just square brackets call the calcium, and then I forgot the semicolon at the end to suppress this output, and we see two things. The first thing is we can see a histogram. But we also see an empty frame, which is, of course, the axis coordinate system waiting to be filled with another plot, because we have said there are two columns now. So we can use that. Just for simplicity, I just copy this code. Now, what will its index be? 0, 1, of course. So axis 1, and then we replace calcium with sodium, and now we get two different histograms, one for the calcium on the left-hand side and one for the sodium on the right-hand side. And if you think they need to be stretched a little bit more, you can adjust the figures and stretch them. And if you want the height changed, you can do that as well. So this is the two things, and maybe just a few more small comments on how to now improve things a little bit. Let's try one thing. Do you remember? Yeah, it was okay. What you can see is that things get very close together if I have a small figure size, and more nicely separated if I have a large figure size. So there's always a possibility that these two things will be overlapped if you have more than one column, like 2 or 3 columns, that these things will get too close together. And the way to make sure that this doesn't happen is to put a call on the figure, which is a function called tight layout. Function with empty parentheses. And this will just make sure that the two columns are actually separated, even if you use, say, a label for the y-axis. Shall we try to put a label on the y-axis so we can access? How do we access? How do we put a label on a certain axis? So we specify the axis. So in this case, it's x0, and you know it's the left figure, right? So axis 0 refers to that figure, and we can access a function called setYLabel, which will put us a label on the y-axis of that axis system. And whatever we want it to show goes into just a string. So in quotes, and in a histogram, that is the count. And you can see the count now shows up. And if I want to have that on the second one as well, I just go there and I specify axis 1 also has a y label of count, and you can see how nicely separated they are. Just for comparison, if I take that figure away and comment it out, they get very close together and even overlap a little bit, which is not nice. So remember the tight layout, which will just make sure these two things are actually apart. Right. So, and this, I think it brings me almost to the end. And of course, you can put, now that you know how the Y label works, of course, you can also put an X label. Now, if you wanted to put an X label, what was it? If you see the calcium, maybe you call it calcium. So you say, give a label to the x-axis. So now you know this left histogram is calcium. And of course, copy and paste and put it on the other system that is sodium. And now we have our nice graph. And if we make it a little bit bigger, then we get a fairly decent graph already. I think in the material, it also shows how to change the font size and many other properties, but I leave that for you to look it up. Right, so we can now import data. We can get an overview of the basic statistics. We can do whatever we want with them, analyze anything. That's, of course, what we're going to do in the end. We can do machine learning, and whatever result we have, we now know how to use Matplotlib to make a graph. Okay, what we don't need at the moment is to save results. We'll have a look at that later. I want to encourage you for this lesson. I can see that the materials that opened on Monday already, people have submitted assignments. Please have a look. It's very simple. The assignment is very easy to do. Just work with what I have just shown you on a different data set. And of course, this is a suggestion. So we say, take that data set and do it sort of to encourage you, get into this habit of opening JupyterLab Notebook, importing the functionality, and get to used to the way this all works. And as a final comment, of course, it's a suggestion, means you can do whatever you like to do. For example, you can roam on the internet and get whatever data you like. So I suggest go on this one here. I can try to put that link into message that to, does it work? Message that to everyone. I think I copied it twice now. So just try it. Get on that link, and that's the government UK. So the UK health ministries, COVID data updated everybody, just as a suggestion. And this is the download page. So each of those good databases has download pages, the biological databases. And if you go to the download page, of course, you can download. And if you just want to follow what we did here, have a look at this, use the CSV format of the data to download them. Then you can import them as a data frame, because if it's CSV format, it will be possible to get it from read CSV. And then you can import it and have a look at them using head. And then you will see this is not one column, there are many columns, and it contains all the, I don't know, counties in the UK and how many people had COVID and how many died and how many are vaccinated, and not everything is somewhere down that download page. So just use it to import things and make a nice figure. If you have a time series, like everything that happened from last March to today, and with the specific date, you can just plot the data as a time series. Deaths going up and down, hopefully down from now onwards to 0, and so on. But anything that you want to do, you might try from there. So that's the government.uk. CSV unstacked or CSV stacked, well, just try both. Somebody asked what type of things. Yes, go there, experiment, have a look at this, download it and see what trouble you get. And if you have trouble, solve it by calling the government, say what do you do on your public health database, or put it on our forum, ask us. We are currently recruiting new tutors, so from next week on, we'll be ready to answer all of your questions. But what it means is data handling is, of course, a generic skill that should be applicable as widely as possible. And we are not here to learn what I'm telling you, but we are here to sort of practice things that can be generically applied. Right, that brings us to 3 o'clock. Sorry for the little delay at the beginning. You had to wait. But now I think we have all groups together, and it's great to see you here, and keep going with me. In 2 weeks' time will be the next webinar, Dataframes 2, where we look at multivariate features. Multivariate referring to the fact that today, when we did this scribe, we looked at the properties of a single column, right? We looked at mean value, minimum, maximum in a single column. Means we ignored the fact that other columns are there, but multivariate analysis means actually, why ignore it? If we have more than one column, why not see whether these have anything in common? It's called multivariate data analysis. And of course, all of machine learning is multivariate data analysis. Okay, and with that nice prospect, thanks for watching today. And say hello, bye to Panda, and bye to you all. And see you in 2 weeks.